A jet engine is a reaction end. That is, an engine which provides propulsion or thrust by expelling a reaction mass and works in accordance with Newton's third law of motion. For every action, force, there is an equal and opposite reaction, force. Gas turbine engine. Most jet engines used in aviation are air-breathing, axial flow, gas turbine engines. A gas turbine is a rotary engine that extracts energy from a flow of combustion gases. Ambient air is drawn into the engine intake, where an axial or a centrifugal compressor, or both, increases both the pressure and temperature of the air before feeding it into the combustion chamber. In the combustion chamber, fuel is added to the hot, compressed air and ignited. Once ignition has occurred, it is self-sustaining as the constant flow of air and fuel provide for continuous combustion. A high-energy exhaust stream, reaction mass, produced by burning fuel/air mixture, leaves the combustion chamber, passing through one or more turbines, which serve to drive the compressors. The remaining exhaust gas is ejected through a nozzle, providing thrust, force, to propel the aircraft forward. A jet engine is made up of a cold and hot section. The cold section includes the intake, bypass ducts, compressor, diffuser, and drive shaft. The hot section consists of a combustion chamber, turbine, nozzle, afterburner, and exhaust. The jet engine works by drawing in cold air, compressing it, mixing it with fuel, combusting it, and then expelling it out of the exhaust. How are jet engines manufactured? Jet engines are large, complex machines that are assembled in parts. Once the design of an engine is approved, the components need to be manufactured. Some of them will be made in-house, but many will be brought in from other companies and then assembled. For example, the Rolls-Royce Trent is made in 8 modules. Major components such as the combustion chamber and compressor are built separately and then married up together at final production. What are the material compositions of the jet engine? Jet engines are made out of many advanced materials due to the extreme loads and environments they experience. Most of the materials are metallic alloys, which include nickel-based alloys, cobalt-based alloys, titanium alloy. Are jet engine components made out of strong, lightweight material? Yes, jet engines must be made out of strong but lightweight materials. This is because a jet engine's thrust-to-weight ratio is one of its most important metrics. It takes an incredible amount of force to fly, so keeping weight to a minimum while maximizing power is a key goal for jet engine manufacturers. After the assembly of the main parts, accessories such as cabling and hydraulics are added. The final stage of manufacture is testing, during which the engine is run on a test bed to ensure it meets the operational performance specification. CFN56 final assembly lane. Step 1. High pressure core assembly. Step 2. Low pressure turbine assembly. Step 3. Accessory gearbox assembly. Step 4. Assembly of equipment and accessories. Step 5. Total visual inspection. Why are jet engines difficult to manufacture? Manufacturing jet engines is extremely difficult due to their extreme operating conditions, as well as the safety requirements an engine has to comply with. Jet engines are subject to extreme thermal, mechanical, and aerodynamic load. They must also have a very low rate of failure for safety reasons. These two factors combined are what make manufacturing jet engines so difficult. Are some jet engine components 3D printed? Yes, some parts of jet engines are 3D printed. While it is challenging to print engine parts due to the mechanical properties required, the production of some parts now includes this method. General Electric's GE9X has 3D printed turbine blades that use the material tile, which is too brittle to be used using other manufacturing techniques. What are the factors that affect jet engine performance? There are many factors that can affect a jet engine's performance. One of the main factors is its operating environment. For example, at sea level in a cold atmosphere, an engine will draw in denser air, which will increase its thrust. Similarly, an increase in altitude or air temperature, or a pressure drop, results in less dense air, which will reduce the engine's thrust. Another variable is the speed of the engine/aircraft. If the aircraft is moving faster than its design intends, then air will form a pressure wave on the engine intake, limiting airflow. If the engine is moving too slowly, it won't receive enough ram air, which can lead to a stall. A turbojet engine is most efficient when the speed of the aircraft that it propels approximates the speed of the exhaust gas. In many cases, aircraft are designed for speeds much slower than that of typical jet exhaust, so the engine turbines are also used to drive other components such as a fan, propeller, or other machinery. In this way, turboprop, turbofan, and turboshaft engines are optimizer for the speed and the type of the aircraft that they power.